Next we have ductable split. But before moving to ductable split, if you talk about window and split, both comes under unitary, means single AC, right? But if you talk about ductable or package or chill water system, VRF case is different. We'll discuss later. All comes under central air conditioning system, because window and split is unitary, means single ACs. But ductable, package and chillers comes under central air conditioning system. So first of all, we'll learn what is central air conditioning system. Any idea online? Class concept of central air conditioning system is the machine is placed somewhere in the building or somewhere in the floor, and we are supplying the air to different spaces by using the circuit called ducting. With the help of ducts, means air passages or air conveyors, metal boxes, we are supplying the air to different places or different means not places, different spaces in the floor or in the building. Means machine is centralized somewhere. But in case of unitary system, means number of spaces equal to number of units. But in case of central air conditioning system, unit is limited. It can be only one big unit or 2 unit will cover the complete floor as per the capacity by using the ducts. Okay, so this is the concept of central air conditioning system. But in this we have different types. So first let me start with ductable split air conditioning system. So already we talked about the split, right? So the bigger version of split is ductable split, right? So the first difference between the split and ductable split, here I can read, ductable machine can be considered as the bigger version of split. The first difference means the split system already we learn 0.75 to 3 TR, and it can increase up to 7 TR as per the location or make, but in general 0.75 to 3 TR. But in case of ductable, start from 3 TR up to 25 TR, or it can increase also as per the make and location, but in general 3 to 25 TR. So the first difference is the capacity. So we can consider the bigger version of split. And why we are considering bigger version of split? Because in this also we are dealing with 2 units. One is outdoor and one is indoor. And the second difference is with option to attach duct. So how exactly? I'll show you. So first of all, in this image, you see this is outdoor unit and this is the indoor unit. The indoor unit is not the wall type or ceiling type. This is concealed above the false ceiling and ceiling suspended, or it can be floor mounted in the AHU room, separate room. Okay, so I'll show you one image here. This unit is called AHU, air handling unit, because capacity is higher. FCU means up to 5 TR. Above 5 TR we are calling AHU. So this unit is AHU, and this unit, if you connect with the outdoor with the refrigerant system, we can call as ductable split, because this unit is common for chill water system even with VRF. So this AHU. So this AHU, if you're connecting with the outdoor unit and we are supplying the refrigerant with the same vapor compression cycle, so this system we can consider as ductable split. So split because of outdoor and indoor. And why we are calling ductable? Because here you'll find the open mouth, and both this mouth for supply only. Suction from backside. Backside you'll find the filter, then the blower, then cooling coil, then the cool air will supply, or else first cooling coil, then blower. We have a draw through and blow through configuration. We'll discuss later. So suction from backside, and the cool air will supply from this mouth, and with this mouth we can connect the duct. The duct can be round, the duct can be oval, the duct can be rectangle with a connector as per the requirement. At present in this image you can see the round duct, means we can connect the duct. So the first is higher capacity compared to split. The second option is we can connect the ducts, right? So what is duct? The duct which is used to convey the air, or which is used to supply the air. But detail about the duct we'll discuss in module 2. At present, in order to learn this ductable system, I'm going to introduce this ducting. But for ducting we have a separate module. In detail we'll discuss. Okay. So here we can attach the duct, and the third option is we can also provide the ventilation, means fresh air as per standard. So how to provide the fresh air? Here you can see this in this image. Suppose this is the exposed wall, and we can cut this exposed wall and we can add a piece of duct, design as per the requirement of fresh air. So for example, as per thumb rule, because fresh air will calculate at the time of load calculation with the standard, Ashtray standard 62 or 62.1 or carrier standard. We have list of standards. We'll discuss at the time of load calculation. But at present, just to understand the concept of this ductable system, for example, fresh air, I'm using say 30% of the total air. And remember this, or we can say 10 to 30%. And this 10 to 30% is as per thumb rule. So when you are using this fresh air 10 to 30% at the time of interview, you must add as per what? Thumb rule. As per thumb rule, not standard. We have a standard. We'll discuss at the time of load calculation. But this is just as per thumb rule. So say 30%. I'm introducing the fresh air by using this piece of duct, and this piece of duct it is bent down like this. Why? Because in case of rainwater, the water will not enter inside. So for that reason, the piece is bent down, and that's the reason we are calling cowl piece, COWL. Cowl piece with bird net and VCD. Bird net means a mesh, because here you'll find the suction pressure. Because when this machine, when this unit, this is what AHU, air handling unit, and ceiling suspended type. Right, it's going to be hang on the ceiling and above the false ceiling. This is what? This is a false ceiling level. And this is above the false ceiling, right? So this machine will suck the air, and here you'll find the filter. You can add this online in classroom. You can add here filter, and return air from this return diffusers, the return diffuser, the return air, and the fresh air. Both will suck by this machine, and this cooling coil, with the cooling coil, the temperature and moisture will leave on the coil, and this blower will supply the air to the duct. So a part of fresh air will introduce with this piece of duct, but cowl because it is bent, and will design as per the requirement of fresh air. So fresh air can be introduced in this. So this machine can provide the temperature, can maintain the RH, can maintain the noise, because outdoor is completely outdoor, and in the indoor also conceal above the false ceiling. And it's not must to place in the conditioned space. We can place away from the conditioned space, like in the pantry area, above the false ceiling or somewhere. So the noise point of view also is less, and we are using the ducts to supply the air uniformly. So motion and distribution. So this will satisfy the requirement of air conditioning. So it's fully approved by the standard society, because window and split will not provide the fresh air, and even distribution of air also not proper. But here in this ductable, it can provide the requirement, or it can satisfy the requirement of air conditioning. So this is fully approved by the standard society. So here for information, this AHU will have the connection, and this connection we can call, you can write FC, nothing but flexible connection. We'll discuss about flexible connection at the time of ducting. This flexible connection means a cloth between the duct and the unit to cut the vibration. It's a canvas cloth. Then this is a connector. Then we'll run the duct, and this duct will have the branches before supplying the air to the air terminals. But branches is not visible here, because at present we are not talking about the duct. We are talking about the ductable unit. That's the reason we are talking about little about the duct. But detail about the ducting, we have a separate module. So next, apart from this, this duct can run through this wall to, you can write, to other spaces. Here I'm writing this duct to other spaces. Why? Because this capacity is higher. This is not only for one space, it can be for multiple space. So this duct will run through the wall to the different spaces and supply the air, and the return air completely back from the space and sucked by the machine. So here the supply diffuser will supply the air, and the return diffuser will suck. Say 70% is return, say 30% fresh air. So here 100%, but we are supplying 100%, but return is 70%. So you'll get the positive pressure. So there should be exhaust of 30%. So generally in case of residential or in case of office, at least in 1 hour, one time the door will open. So exhaust through the door. But in case of closed rooms, we require a separate exhaust duct also with the fan, so that how much we are taking the fresh air, that can be exhaust, right? So anyhow, that balancing of air we'll discuss at the time of ducting. At present, just you understand how this ductable system works. That's it. Even as I said, na, chapter 8 is related to chapter 5. At present, we are at chapter 5. So after learning this, after load calculation, we'll go for machine selection of what? Of the same system. So at that time, we'll discuss the technical part of this machine. At present, we are learning how the system works, the capacity, the arrangement, etc. The appearance. Okay. So online classroom, anything to discuss? Did you update this? AHU, FC. FC is important. Even the filter also important. And here, if you talk about this lines, you see the direction. This the arrow is going up, na. So this is what from outdoor to indoor is liquid line, and return is what? This is suction line, nothing but gas line. Return back to the outdoor unit. And one more point is missing. The drain pipe is missing here. So I'm going to add the drain pipe because drain pipe is required, na, with what? With the U-trap. So you add here drain pipe. You can write PVC drain with what? With U-trap. Okay. So remember FC or AHU, we require drain pipe to drain the condensed water from the room air. The water from the room air only, na? But don't worry. As I said, na, we have a separate topic about all these ducting A terminals in module 2. At present, just to understand the system, we are talking about this ducting, diffuser, etc. But we have types of A terminals, duct designing, etc. in module 2. Okay. And here the return air diffuser without any duct. So this is called free return. But in some cases, you will find the return with the duct also, with the return air duct. Why when return air duct is required, when we are dealing with the free return, all this we'll discuss in module 2. At present, just learn how the system works. That's it. Yes, online.
Could you repeat the capacity of cassette type and cable type?
You see, for split, mini split, the capacity up to 3 TR for mini split. But for ductable split, start from 3 TR up to 25 TR in general. And it is higher also available with some brand in some location, but in general 3 to 25 TR. Okay, for ductable. And it's a ceiling suspended type and conceal, which is not visible in the conditioner space, so will not affect to the interior also. Okay, so we have some more theory to discuss in the next page. So here you see advantages. Ventilation is possible as per standard. If you are following ASHRAE or SIPSI, whatever, we can follow the ventilation standard. Next, central air conditioning system, and it is concealed type, will not affect to the interior. Means what? Concealed type AHU. The indoor unit is concealed. Outdoor is outdoor only, but indoor also not visible. It's above the false ceiling. Okay. Next, low noise. Why? Because outdoor is outside and inside also above the false ceiling, and even inside the ducting we are using a lining called acoustic lining to reduce the noise. And how to deal with acoustic lining we'll discuss at the time of duct insulation. Next, uniform distribution with the help of ducts. So these are the advantages, and disadvantages same. Compared to chiller, the running cost is high. This disadvantage you'll find in all the system except chiller. So compared to chiller, the running cost is high. So still this point is pending, because after learning chiller only you can understand how this systems having more running cost compared to chiller. So after learning chiller you'll get the idea, don't worry. Next, capacity 3 to 25 TR. For example, as per Carrier brand, the range configuration is given 3 TR, 4 TR, 5, then 5.5, 11, sorry 7.5, 8.5, 11 TR, and directly 17 TR is the maximum available in Carrier. But in Blue Star it's available up to 22, in Daikin 25, etc. So depends. So in general 3 to 25 TR. Okay. Next, application, restaurants, villas, hospital, and if you go to any supermarket in India most commonly this system is used. In Gulf, most commonly we are using package. Similarly in India, most commonly we are using this ductable. So if you go to any Reliance Fresh, Big Bazaar, D-Mart, or Reliance Digital, or Vishal Mega Mart, and this this brand factory, in all this area you'll find the ductable split only. Ductable is most commonly used in India. For medium, even for big project, the people are big project means I'm not talking about high-rise building like big bazaar. Big bazaar is a big area, not very big. Or else you can consider a small or medium type of project. We can use this duct table. So very commonly in India. Because the initial cost is less. Because in chill water system, the initial cost is high. So chill water system generally you use for big high-rise building or the big project like a laboratory or a hospital or a high-rise building, etc. We'll discuss at the end. Next requirement, hard copper pipe is required. Hard copper pipe means we have two types of copper pipe. One is soft run and second is hard run. Soft run means this is soft copper pipe. And if you want to, suppose we are taking the pipe straight, then if you want to turn to 90 degrees, so we have a tool called bender. With the bender we can press and it can bend to 90 degrees. We don't require a separate fitting in case of soft. So generally the soft copper is used for mini split with the limited capacity. But for ductable the capacity is higher now, so we cannot use this. We require the hard copper pipe like this. And for hard copper pipe, if you want to take 90 degrees turn, we require separate elbow or fittings like this. These are all fittings with the bracing on site. Okay, T, elbow, etc. Okay, so hard copper pipe because the capacity is higher. So soft copper pipe if you use, it will burst. So we require hard copper pipe for ductable split. So this is about the ductable split.